Good afternoon. In this lesson, we're going to be talking about what makes up bone and why bone is such a good building material or support material for our bodies. Now, as a building material, bone is perfect for our purposes as humans. Consider this question. Why are skyscrapers made of steel and not wood? Well, most of you are going to quickly say, a skyscraper being much taller is going to need a lot more support and a lot more strength to go up 60, 70 stories. Wood wouldn't be strong enough to support it. And at the same time, you might ask yourself, when you look at your house, why is your house made of wood, not steel? Well, can you imagine a construction site, contractors, carpenters carrying 2x4s around of solid steel? Very impractical. One man couldn't carry them by themselves. Plus, how do you cut them? So, bone has to take a little balance here. It has to be light enough that we can move it around, yet it's got to be strong to support our entire frame. Now, a few terms that we're going to be looking at as we go through here, point them out on this slide right here. This is a typical long bone. And it's called a long bone because it is longer than it is wide. In this long bone, the ends are called the epiphysis. So this is the proximal epiphysis of the tibia. This is the distal epiphysis of the tibia. The middle part, that's the shaft. Now, between the epiphysis and the diaphysis, in this particular picture, you have something called the epiphyseal plate, right here. That's also called the growth plate. You also have a medullary cavity, which is the middle part. Now, the medullary cavity is either going to be made of red marrow or yellow marrow. Now, in this cross section that you're looking at of a bone, you see two other components here. You see the outer cover right here, which is compact bone, and it's got a nice smooth appearance to it. You also see right inside of that spongy bone, and it gets its name because it does have lots of pores in it. Also, you have this center part that in this bone piece here that was cut from, I believe that was cut from a buffalo or something, and so all the middle part is gone. This is the medullary cavity. In a living bone, this medullary cavity is filled with a substance called marrow. Now, in children, the marrow is red. Red marrow is producing blood cells, both red and white blood cells. Yet in adults, as they get older, the red marrow changes to yellow. Yellow marrow is basically just fat. It really doesn't function in producing blood cells. Now you should be asking yourself, why is bone made up of two kinds of tissue? Why is it made up of compact bone and spongy bone? Well, consider this. At some point in our careers as students and teachers, we've probably all in some time made what we call toothpick bridges. Now, this exercise is generally designed to figure out how we can make a bridge that supports the most weight. And I'm sure you've figured out by now that this kind of a support system works the best to distribute the weight. A series of triangles built around themselves. This is a truss bridge. Now, this has always traditionally worked the best. Well, bones are just like those truss bridges. Look right here. See how these lines go across here, and they also come across like this? Those are the trusses that you at one time saw up here. So, if this type of a toothpick bridge gives you maximum support for amount of force, it's going to do the same thing down here in the bone. These little structures are called trabeculae. That's the bone's trusses. Now there's a law of anatomy here that says that wherever bone is going to be stressed, this is where you're going to develop these big truss lines and also a thickening of the bone. This is what physiologists call Wolff's Law. Wolff's Law simply says that wherever there is stress applied to the bone will respond by either making the bone thicker or applying these trusses. More than just having, a truss system and thick bone here, there's two important parts to the whole part of bone here that really makes bone strong. First, like we've all heard before, drink lots of calcium, makes your bones hard. Drink lots of milk, makes your bones hard. Well, milk contains a lot of calcium. Calcium is one of the key things that makes your bones hard, gives them their strength. Consider this picture. This unfortunate individual has a case of what we call rickets. In this case, the bones of the legs are so deformed because they cannot support the weight of the person. The calcium is either lacking, either their diet is poor in calcium, or they're lacking vitamin D, because you need vitamin D to absorb calcium from the blood. So something has happened here, either lack of vitamin D or lack of calcium, to keep these bones from absorbing the calcium into the bones. So these would be bones that have no calcium in them. Now, the second component making bones strong are proteins. In particular, proteins, the protein is called collagen. That keeps the bones from becoming too brittle. Now, the way protein fibers work, if anybody has ever worked with fiberglass before, kind of know what I'm talking about. Fiberglass contains long threads, and these long threads or strands of fiberglass have a chemical bonded to them, and when it all dries, the material is very, very hard. Well, we have the same thing right here, only instead of long threads of fiber, we have collagen, which is a protein. That collagen is attached to calcium. So the calcium makes this very, very tough and keeps the bones nice and stiff. Now you're going to be doing a lab, and in this lab you're going to explore where we're going to have you actually take calcium out of some bones and observe the effects, and take some proteins out of the bones and observe the effects. So be watching for this in the lab, in the upcoming lab.